Can we start, sir?
Yeah.
Okay, sir. So, with your kind permission and blessings, let's start. Good morning, participants. I, Dr. Jitendra Jain, coordinator of this faculty development program on outcome-based education, welcome you all in the first session of this FDP. In this today's morning session, we are going to start technical session from the 9 to 10:30 a.m. and then from 10:30 we will be having our inaugural function, and after that there is a central inaugural function by AICT ATAL Academy, and we will share live streaming of that program also. So now let's start our first technical session. It's a matter of privilege to have Professor RANJAN Maheshwari sir, Professor Rajasthan Technical University Kota, as an expert in the first session. He is going to deliver an expert talk on introduction to outcome-based education. He is having a very vast experience of teaching and research, and he is my teacher, my research supervisor as well. I welcome you, sir, again.
Thank you. Thank you.
So before starting the session, let me read out a brief bio sketch of Professor RANJAN Maheshwari sir. Professor Maheshwari sir did his bachelor's degree in 1987 from MNIT Jaipur and post-graduation in 1996 from IIT Roorkee, and then PhD in 2007 again from IIT Roorkee. Currently, he is professor in electronics and instrumentation engineering at Rajasthan Technical University Kota and is serving for more than 27 years there. He has been director of National Institute of Electronics and Information Technology, NILIT, Aurangabad, from 2013 to 2015. He is a board of members at Baba Saheb Ambedkar Marathwada University, Aurangabad. He has been visiting faculty at many reputed institutions like Asian Institute of Technology, Bangkok, Atal Bihari Vajpayee, Triple IT, Gwalior for 6 years, and SPNIT Surat. During uh, teaching at RTU Kota, he has worked at many administrative posts like head of department, member of board of studies, coordinator, MTech centralized admission process, examination in charge, member of department research committee, member of academic council, etc. He is also the member of many professional societies like Indian Society for Technical Education, Indian Society of Electrocardiology, fellow member of IETE. He has published more than 30 research papers in national and international journals and conferences. He has guided 4 PhD students, including me. My he has one patent in his name and one book chapter also. He is a very great author and has written more than 100 blogs at Now Bharat Times. His area of interest are signal processing, measurement and instrumentation, biomedical engineering, and electrocardiogram signal analysis, effect of venom on biosignal. In fact, he has done a lot of research work on effect of venom on electrocardiogram. So today, such a valuable and resourceful person is with us. So now, without taking much time, I welcome you, sir, again, and request you to kindly start the session. Over to you, sir. Hello.
Sir, I think you have to call, sir. Maybe some network problem at sir's side.
Yes, yes, yes. I think he has left the meeting and will join soon.
Yes, sir, it seems. We can wait. Sir has joined.
I'm sorry. Somehow it has gone off.
It's fine, sir. It's okay.
It's okay.
I'm
It
sorry,
happens.
sorry. But it has created actually raised heartbeats, no?
No, it's
It's Jitan's subject, actually, heart rate variability. Suddenly
Yes,
it has
sir.
given me a shock. And initially the
area of
heart rate,
interest of Jain sir also.
the heart rate got down a little and then it raised.
Oh,
It was a shock rather. Anyway, so good morning everyone, participants. I'm sorry because of this hiccup. So it was a basically kick start, we should say. Well, we are today studying about this outcome-based education, but the first lesson we have learned just now that if something can go wrong, it will definitely go wrong. I was worried a few minutes ago that system may go wrong and something may go off, and suddenly sharp at 9 o'clock there was a dip. Anyway, now my topic today is outcome-based education. In fact, for the next 15 lectures, 14 lectures, 15 lectures, we will be studying basically the outcome-based education only. We will be studying the different components of this National Board of Accreditation's methodology of how do we assess the institutions, etc., etc. But all these things, they are centered around the outcome-based education. So let us start, and I'll just be sharing my PPT with you, and then we will see that is my PPT visible?
no, sir.
Not yet, yes, sir. Not yet. Yeah.
Yes, yes, it's coming, sir.
Yes, yeah, it's coming
Done,
up.
sir. Perfect.
Okay. So the outcome-based education we will be discussing, and for that, on the onset, I should pay my homages to Professor N.J. Rao, former professor of ISC Bangalore, and Professor Hugh from this Johannesburg, University of Johannesburg, South Africa. They are the two people who have done extensive work on this outcome-based education, and we have been fortunately having both the gentlemen over here, and they are still continuously working. Both of them are pioneers, we should say, in outcome-based education. And so what I am presenting is just a glimpse, or rather a tip of the iceberg, which I have learned from these two Nobel laureates. Okay. So the main objective of education, let us say, if we can say, is to equip the student with a good quality of education. And what is education? Education is nothing but its enrichment of culture, character, and personality development, and cultivation of noble ideals. That is the education. There may be difference of opinion amongst us also, but more or less, education is simply enrichment of all the good characters, or rather all the good features in a person. So, in fact, the objective is gaining the mental, physical, and intellectual personality of students to make the student future ready and survive in any situation. And for that, I'm thankful to this paper, or rather book, Indian Education, Ancient, Medieval, and Modern by Mangesh Ghonge, Rohit Bagh, and Aniket Singh. And this book is available on the ResearchGate also, as well as you can buy online also. So, in fact, after having gone through this book, I found that the objectives of education have not changed much. And even in today's latest NEP also, National Education Policy also, we can see that we are thriving for this holistic education. And this holistic education again is nothing but it is the repetition of the same thing, but rather more enforcement and breaking the silos of watertight compartments amongst the various branches of education. So the history of today's engineering education, let us say, if we study, I think some of you must have already been there in 1990s. 1990s was a period which had brought before the world a big challenge, and that big challenge was Y2K problem. Because when the computerization in banks started, typically in the developed countries in the 1950s and 1960s, at the time they had not envisaged that what will happen by the end of the century. So usually what they do, they kept only 2 digits for the year mark. Okay, so years used to be represented like 59, 60, 61, 62, etc., etc. But nobody had thought that what will happen after 98, 97, 98, 99, and then what? Then the figure of 00 representing the year 2000 would have brought a havoc to many banks, because all the calculations would have gone in a very absurd manner against the interest of the banks. Like if they calculate how much interest is to be taken from the person, then every year which was progressing and which was increasing for 1 year, suddenly from 99 to 00, it would have returned the interest of a century to that person. Okay, so this type of problems would have had been there had this problem had not been there. So if you remember, some of you who might be there present at the time, that there was a lot of demand for engineers, and typically from India, who can work and who can make some space so that the 2-digit figure can be converted into 4-digit figure, and so it was like that. So then the debate started about the engineering education, that should our education should be so narrow that we are not ready for the future? Or because this was just one problem, there might have been another problem also, there might be multiple problems, and there might have been many associated problems also. So everybody was thinking that no, the education should change. So earlier, the engineering education and other things were certainly be there, but main emphasis was not on the holistic part, but it was just that so that we should fit in as a part of some machinery. Now the thing was that engineering education had to be overhauled, and now it should have been converted into a specific. It should have catered to a specific purpose. So all those gentle and noble people from various countries, they sat together, and they reached a remarkable consensus to move from the input-focused accreditation criteria to an output-based specialization. And after churning for about 15 years or so, by 2005, they reached a consensus that was called Washington Accord. And initially there were only 8 signatories, and then later on it significantly expanded into Asia, because a large number of candidates in European countries as well as in America, they come from Asia, typically India, Pakistan, Bangladesh, and Malaysia. So what they did, they expanded it to the Asian countries also, and there had to be a common thing, a common platform that they called as the graduate attributes. Okay, amongst this. So let us say Washington Accord, what it is, that it was established in 1989, and it is an international accreditation agreement for undergraduate professional engineering academic degrees. Yes, many of you must have had this doubt also and might be asking this question also, that our NBA, National Board of Accreditation, it accredits the postgraduate programs also. But in fact, the Washington Accord is primarily meant for undergraduate professional degrees. But our National Board of Accreditation, which is again following the Washington Accord's norms, it gives the accreditation to our postgraduate programs as well. Okay. So Washington Accord is between the bodies responsible for accreditation in its signatory countries and regions. Then again, there is some difference you can find out, that signatory countries and then regions. There is slight differences because many of the countries, they share the academic programs. Okay, so if one program is applicable at one, they say it is applicable at other also. And so in certain cases, the boundaries of countries are not there, but of the regions are there. Like in Russia. In Russia, what is happening that even after the countries have been separated, their education system is still almost similar, and they are following the same sort of norms. The Washington Accord covers only the undergraduate engineering degrees. Why? There is a reason that usually the movement of students from one country to the other is usually at the graduate level. Okay, at postgraduate and PhD level, this movement is not that much. So that's why this accord primarily caters to the undergraduate engineering degrees. And bigger thing is that if the standards are set for, let us say, undergraduate engineering degrees, post-graduation is only enhancement, and post-graduation is nothing but it is only specialization. So it will be automatically falling into place once the engineering graduate degrees are coming to picture. So this Washington Accord specifies that a graduate should have 12 attributes. Attributes, I think you all know. Attributes, when you, let us say, you look at, let us say, something of copper. If I say to give me the attributes of copper, the very first thing somebody will say that it is a metal. Electronics and electrical engineers will say that it is a very good conductor. Okay, somebody from, let us say, should say marketing and some, that it is very bright, shining, and it is got good cost. Means it is costly, expensive. People from mechanical engineering will say that it is malleable, it can be converted into any shape, etc., etc. And people from jewelry and other things, they will say that it can be molded into, and fine work can be done onto it, etc., etc. And somebody from, let us say, Ayurveda will say that if something is made of this copper, then it is good for health. So what are the attributes of copper? Copper's attributes are very simple. It is a metal which is very good conductor. It is having some this corrosive nature also. And please switch off the mic if somebody is accidentally opened it. Okay. But if you have any question, you can always ask in between. Okay. So there have to be 12 attributes. So in copper also, let us say some attributes are there. And if we like it, certainly we'll be selecting that particular material. But if you want to have some specific properties in your product, then certainly you'll be going for other material, etc., etc. So attributes are nothing but they're called properties in a broader sense, we can say. So in India, what we have done, that we have opted the 12 attributes as POs or program outcomes, but with the some small changes in them. Okay. So graduate attributes are, they provide basically an exemplar of an outcomes specification, outcomes based specifications. Like when a candidate or a graduate, when he is passing out of an institute, then these are the properties we think the graduate should have. And these are basically the programs that provide the educational base for the professional engineers. Mind it, we are trying to make the engineers not for the offices, but we are more interested in making the engineers for, let us say, professional degree holders. Means they can do certain specific work which are generally, should say, attributed to engineers. So bigger thing, the most bright and most beautiful thing is that this graduate attributes, we simply say that this is what we want finally in the engineers. So it is up to the institute left that how they will be inculcating this type of attributes in the students. So you can design your own program. Every institute is free to design their own program, and that is the biggest beauty of it, that we simply want that we are only interested in the outcome of your institute. So you can design the program whichever way you want, but finally you should have this type of attributes in your students. But there are certain interesting things if you start studying deeply into the Washington Accord and this entire process. That Washington Accord specifies its own level of knowledge and proficiency. Okay, those who have already studied Bloom's taxonomy, they must be knowing it, that most of the institutions in India, they have opted for the Bloom's taxonomy. Then there are obviously two versions of it, original as well as the revised Bloom's taxonomy, for knowledge, affective domain, and psychomotor domain. Okay, in knowledge domain we have usually 6 levels. Certainly we'll be studying all these things tomorrow, but those who have been associated with, let us say, our this Board of Secondary Education, CBSE, they must be knowing it very well, that the question paper is again based on Bloom's taxonomy and how it to be solved, etc., etc. So Bloom's taxonomy is very widely used in our this Board of Secondary Education. And interestingly, if somebody must have studied about the Robert Bloom spent a significant part of his life in India also. He was invited by Pandit Jawaharlal Nehru, our first Prime Minister, and he came, he saw our education system, and then it certainly affected Bloom's own this philosophy. And so finally when he gave this taxonomy that is being used. Taxonomy is a very simple thing, that you have to use various verbs to assess certain knowledge level, affective domain, psychomotor level. Okay, so that is what taxonomy is all about. But behind this taxonomy there is a great philosophy that different levels can be assessed with the help of this. So the Washington Accord, in the knowledge domain, they have WK levels. They are specific to this GAPO only, and thus the adoption is too less, because the levels have increased from, let us say, 6 to 8. They have changed. And second thing is that there is no methodology how to adopt them. Okay. So Bloom's taxonomy, which is very generic, very simple and very easy to relate with, is still popular. And so let us have a look at the WK levels, and then we will be moving further. So WK1 is a systematic theory-based understanding of natural sciences applicable to the discipline. Now, it is very vague. It is very difficult to, let us say, correlate. And any paper will be, yeah, someone said something? Okay. Now, WK2 is related with mathematics, numerical analysis, statistics, and formal aspects of computation. Okay. So WK1 and WK2 are not related. Whereas in the Bloom's taxonomy, this, let us say, the first level forms the basis of the second level. And so there are a pyramid structure in Bloom's taxonomy, whereas in this WK levels, in this Washington Accord, it's not so. So that's why people are not opting to that. And WK8, this is engagement with the selective knowledge in the research literature of the discipline. Now it is altogether very, very vague. Okay. And WK8 is not directly related to WK7 or WK6 even. So that's why there are a lot of confusions in this WK levels. And so sometimes it is also possible that somebody may be very much proficient in WK8, but may not have, I should say, the proficiency in WK5 or WK6 or even WK2 even. So that's how it is something very difficult, that how many levels in this Washington Accords, this knowledge levels we can get in. So that's why people are still opting for the Bloom's taxonomy, and it is in NBA it is very much acceptable. NBA, if you are means defining the levels in Bloom's taxonomy, they rather appreciate it. Okay. Now we come on to the outcome-based education. What it is outcome-based education? This was all about the background. So broadly, we can say that in outcome-based education, it is an educational theory that bases each part of an education system around goals or the outcomes. Means whatever you are doing, you should know, you should be aware that why you are doing it. In Gita's term, if we say that one has to be chetan, or you are conscious that why you are doing it, how it will be affecting the outcome of yours. So each part of your education system should be around some goal. And by the end of the educational experience, each student should have achieved the goal. We expect that all the students, they should reach the outcome, and at least, even if it is 20%, 30%, 40%, or whatever be the degree, but each student should have achieved the goal. That is very, very important, the outcome-based education. Then only we will be able to justify it. So why we should opt for? So with the changing realities spurred by globalization, there is a shift from education as transmission of expert knowledge to education as building learner competencies, including learning how to learn. That's very important. Earlier, what used to be that teacher used to deliver a lecture, and he used to say that I have passed on the knowledge to the student. Now it is students' work to read it, mug it, understand it, or whatever it is the student has to do, and then reproduce it in the examination, and then the assessment will be done and my job will be over. No, it is not longer like that. It is that we have to build the learner's competencies. Even the student should learn how to learn, so that he can be very effective, very efficient in learning also. And that is what is the crux of outcome-based education. And you will be glad to learn, or rather you must be knowing it already, that in our ancient education system also it was like that. We used to say that शिक्षा कभी समाप्त नहीं होती, दीक्षा हो जाती है. Means a formal education you can have finished, but informal education continues. So the learning continues throughout your life, but not the, we should say that if you know how to learn or how to get education informally, it goes with your life, and so it is lifelong learning. So the focus is on retaining and learning new skills or competencies day by day. If you have a quest to learn something new, always and every day, then only it is the outcome-based education's success. That it would enable individual to cope with the demand of the rapidly changing workplace. This is important. You all must have also seen it, that earlier we were having, let us say, Windows 95. Prior to that, we were working in MS-DOS. Then after 95, we had 98. Then Windows, this XP, then Millennium. Then it went away. Then came this Windows Vista. Then Windows 7, Windows 8. Now it is working on Windows 12, 10, and it is getting obsolete soon. And then we'll be having now new Windows. The same thing applies with the other type of software also, other type of tools also. And like earlier, a very simple example, being an electronics engineer, I should say that earlier we used to have TVs, televisions, very large television. Nowadays we have very thin television. Okay. So our entire technology has changed. Our workplace has also changed with it. Earlier, if you see, we used to have this CROs, cathode ray oscilloscopes. There used to be, in fact, cathode ray tubes in them, and they used to be very, very large. Nowadays, with this Chinese technology and Chinese vendors, now you can have a very small, or rather very flat, you should say, this CRO. Now it is no longer a CRO. It is because it does not having a cathode ray tube in it, but the name still exists. It is CRO, and this CRO is just like your mobile phone. You can simply connect two wires, and then you can get the output. You can put it in your pocket. You can take it, and the cost is very, very less. From 3,000 rupees to 10,000 rupees, you can get a CRO nowadays. So it is changing. Many of the tools you must not have seen when you were a student. I belong to that generation which had studied vacuum tubes in first year and second year. And we used to make very large circuits. But when we came to third year, then transistors came into picture and the pentode was removed, and then we were working on transistors. And nowadays, even transistors are also not seen so frequently. Nowadays, what we see are the IC chips. And nowadays, even this surface-mounted devices are there. So even you do not see the legs also. You simply see the this layer, they should say, surface-mounted devices connections, and you simply solder them, and etc. etc. In my life, we have seen the wave soldering machine, and now even the wave soldering machine is also obsolete. Nowadays, we simply have the paste, and then with the paste, you can do the soldering. You just put the thing on, and then we heat up, and it gets here soldered. So there are rapidly changing things. So if you do not change yourself with the changing world or changing workplace, you will become a fossil in your own lifetime. So that's why our education should enable the individual to cope with the demand of the rapid changes. So what is OBE now? So OBE emphasizes on stating what you want your students to be able to do at the end of the program. Now we are coming to the task. Okay. So various components of OBE, now they will be falling into places. And based on that, your entire structure will be formed. Okay. So very first question, what you want your students should be able to do at the end of the program, and this will be the first question. Second question is assessing the students whether they are able to do what they are expected to do. You give a question paper to them, give some task to them, and try to find out whether they are able to do what they are expected to do. Then third thing is orienting teaching and other academic process to facilitate students to do what they are expected to do. We have to transform our teaching also and other academic processes. And just like that in Corona, you must have seen, we are unable to have a laboratory in place. But there are software available. So ask your students to work on the software. And so you can have an electronics laboratory simulated in your computer. You can do things on them, hands on there. You can learn the concepts over there. You can have various probes connected. You can have the CRO online. You can have voltmeter online. You can have multimeter online. You can have ammeter online, and any number you want. In software, you can make the adjustment and you can get the feel. So you can inculcate the same thing in your lecture also. And when you go offline, again, these tools are available with you. So you can enrich your teaching so that the students can do better. And the students are prepared. If say some situation comes tomorrow, then they will be able to cope with it. So what they're expected to do, you should orient the teaching and academic processes accordingly. So, what are the key components of the outcome-based education? Yeah, any question? Somebody switched on the mic? Okay. So, very first thing in your outcome-based education is important is what is your vision and what is your mission. Then we define the program's educational objectives. Then we define the program outcomes. Then we measure the attainment of program outcomes, and also we have the continuous quality improvement system and processes. Because whenever you find that whenever the program outcomes are not reaching to the attainment level you have set, or even if they have reached, what is the progress you want in the attainment, then how you can improve the quality further. You have to think innovatively and then you have to do it. Or you have to take some steps accordingly. So outcome-based education is nothing but it is quantification of the quality of the students, not just mark sheet only, but in terms of, let us say, program outcomes. We quantify it in a whole, means an entire class outcomes we usually see as a whole, and then we try to find out that if there is any gap, if any lapse is there, we have to we have to improve the things, and so we should go for the continuous quality improvement. So this process is self-explanatory. It will help you once this process is in place. It will certainly help you in enhancing your quality. So what are the levels of outcome? Because this is outcome-based education. So at every level, we should have outcomes and then we should measure. So very first thing is the program's educational objectives. Their POs are broad statements that describe the career and professional accomplishment in 4 to 5 years after the graduation. And this is what the program is prepared the graduates to achieve with some experience. That's important. That after 4 years or 5 years, if the student looks back and tries to assess them himself or his colleagues, and then whether he is able to describe the career and its professional accomplishment, that is the program's educational objectives. Then program outcomes. They are the statements obviously taken from this graduate attributes of the Washington Accord, and they describe the students graduating from engineering program should be able to do at the time of graduation. So program outcomes, in fact, they are being mapped in your entire this graduating program simultaneously. Then you have program specific outcomes. They are the statements that describe of a specific engineering program what is special in it will be able to do at the time of graduation. So mind it, the POs are defined for the entire country. As far as India is concerned, POs have been defined by National Board of Accreditation. For us, these 12 POs, they are consistent. They are very generic. So it is not like that they are meant for electronics or civil or nothing. You can have the POs, means we should say specific engineering programs can fit in over there. But PSOs, you can define on your own. There may be 2 PSOs, 3 PSOs, or 4 PSOs, depending upon your capability and your diversity. You can have PSOs, and they are specific to your particular program. And that PSOs, they will be somewhat, let us say, you should say, cherry on the cake. Okay, so there are something additional things which you will be defining for your own institute. And the basis of all these things, yes, somebody wants to ask anything? Hello? So mic was on, huh? Okay. And the basis of all these things, how do we get to know whether the PO has been attained, whether PO has been attained or PSO has been attained, is the course outcomes. So COs are basically the statements that describe what students should be able to do at the end of the course. So this is, we should say, the basic building block for your course, and how we will see how we implement them. So this was engineering education in India until 2015. So till 2015, actually we were somewhat, we should say, late signatories in NBA, and we have started the things a little late. But still, in 2000, this is the scenario of 2015, when a graduate of 12th standard used to enter into the institution, and all our regulatory bodies parents, industry, technology, etc., all used to focus around the institutes which are offering the undergraduate programs, and they were churning the institute, but nobody was worried about the process at all. So all the physical entities of the institutes, etc., they used to be studied and they used to be, let us say, assessed. So there used to be somewhat, I should say, very static type of, or rather we should say, monotonous type of this assessment used to be there with the institutions. And then what used to be the engineering graduates used to be there, they used to pass the examination, and then market factors used to come into picture, social factors used to come into picture, economic factors, etc., and then placement, etc. After having passed through all these things, the student used to get placement, or they used to go for higher education, or they used to go for entrepreneurship, whatever it is. But the thing was that more emphasis on the regulatory bodies as well as other stakeholders was on the institutions. But this focus has to be shifted, and it was shifted in the OBE framework. And what it was, that now all these stakeholders focus is now on the process. Yes, it is the institutions, they are the facilitator. They have to change, they have to make the systems accordingly. But we are more interested in the quality of the produce. We are not interested in the facilities the institute provides. We are more interested in effective use of the quality of the resources so that your product is enhanced. And so with the engineering graduates now, they will be able to have the abilities to define the POs, PSOs and COs, etc. And so when they come out for placement, higher education, etc., etc., after, let us say, a significant time of about 4 to 5 years in the professional career, then we assess the program's educational objective also. So nowadays what is happening? It is not that the engineering graduate is coming out and your job is over. No, no, no. Nowadays, even after 4 or 5 years, the PEOs will define your entire process. So in fact, this closed loop has been very much strengthened, or rather we should say it has been tightened. And so it is, let us say, in marketing terms, we can say it is an extended warranty type of thing we are having nowadays. So what are the benefits of OBE? That the clarity. Number one, the student understands what is expected to them and teachers know what they need to teach. Because we have done this experiment also. In the very first lecture, I tell the students about the OBE, that what are the graduate attributes, what are the course outcomes, okay, and what are the POs, etc., etc. I will simply tell them that this is what we want you to be. This is our expectation. Okay, so you should reach this, you should become this. Whether you come to the class or you not come to the class, you do the assignment or not, the thing is that, but I want that you should be able to get it. The student automatically becomes sincere, and now I have seen that the attendance in my class, they have increased. Then flexibility. There is not a specific method of instruction, and we leave the instructor free to innovate and diversify the teaching. Even you must have heard about this flipped classroom also, where in the classroom you discuss only the problems. The background studies and the knowledge collection part, or other the research, etc., all the student is doing on their own, and then they are coming to the class. So we become, earlier it used to be teacher-centric class, then it became student-centric class. Nowadays, we are outcome-based, or rather goal-oriented class in a way. Then comparison. Earlier, there used to be a cutthroat competition amongst the students. Then we had implemented the grade system so that we can bring the students together in one particular this class, so that there is no cutthroat competition, and the camaraderie should increase, etc., etc. So nowadays, it is not the students among which the comparison is there, but now it is amongst the institutions and their outcomes. Even this comparison is now, you can see in various departments also in one institute, and various in methodologies also. And so best practices are also coming up, and then other people are adopting them. And so there are a lot of improvements we can see. And bigger thing is that nowadays we are having involvement of all the stakeholders of not only the students and the teachers. Because in OBE, we take the survey from, let us say, parents also, we take survey from the, let us say, employers also, we take the survey from the institutions of higher education, where our students have gone. Even the entrepreneurs are there, we can take the survey from their customers also. And even the people who are not at all related with the students, but what the general image they project, so and from the society also, we can take the survey. So there are means involvement in development or other in this quality improvement of education. Everybody is involved into it. But there are certain drawbacks of OBE also. The very first thing is loss of conceptualization. Because you have given the student a particular task. आपको ये करना है. You have to become like this. So what happens? The student has become task oriented. So the basic concepts, they do not care much. And in a way, I feel that somewhat the holistic approach of learning is lost. Okay. There are many things we can discuss about it. And those who have experienced this coaching methodology also, in coaching they teach how to crack the JEE examination. So what happens? The students do not concentrate upon the concepts, but they concentrate upon the methods through which they can crack the JEE. So the conceptualization was lost there, and the conceptualization is getting lost in OBE also to some extent, I have felt. Assessment. Assessment is very, very important part in any teaching learning. And if in OBE, if the assessment is not designed carefully, then it will become too much mechanical. While doing the assessment, the teacher should also have very broad mind. He should also, or he or she should also take into account what can be the different aspects of any this PO or CO, and how it can be catered through other means also, etc., etc., etc. Certainly, when we are doing the COPO attainment, at the time we will be seeing it. Then generality. This is another big drawback of OBE, that the unique, the God-gifted, talented, and extraordinary students, they are ignored. Because we are more interested in the result of the entire class and of not one student. If I have, let us say, one student who is having, let us say, an IQ of, let us say, 187, and other student is having, let us say, IQ of about 80. Okay. Then in OBE, instead of this, I would prefer two students having IQ of, let us say, 120 or even 110 will be okay for me. So, because they will improve my result. But the thing is that if I can have some extraordinary students, they will certainly be enlightening a lot of people. They will become inspiration for many others. Sometimes they will become, let us say, Nobel laureates, or they will be inventors or something of that sort. But we do not have any provision of encouragement in OBE that way. And in fact, we have a very constrained nature of teaching and assessment. That we are more interested, because time is usually very less for teaching learning also for us. We have many subjects to teach. We have many other tasks nowadays. So what happens? That we are given a limited time to teach, means one semester. We have to do all these experiments and that. So there are certain constraints. And so many finer values of education are lost in this, and which have been earlier very important. So there is no doubt that India already is not producing the Nobel laureates, but with this implementation of OBE, our trend will be to produce good main force, good workforce for the other countries and for our country, but we are not focusing on producing the Nobel laureates or rather the highly talented, this unique people who can become the lamppost of our this society. And then involvement. Sometimes the involvement is desired and sometimes it is not sustainable, because every time you go and ask parents, every time you go and ask other people, sometimes they become fed up. And so their answer sometimes may be erroneous. And so there has to be some judicious way of doing it. We have seen in number of cases that when we're releasing a survey questionnaire, then what happens that only a particular group of parents, they only respond. Rest of the people are either ignorant or they are not much involved. And when our desired number is achieved, we simply say that, okay, let us stop now. So we never care for the people who have not responded. While it should be there that we should ask them that why you are not responding, you should also respond. Then what is the problem? Because the problems will be told by the people who are least interested in answering your questions. So that way, a goody picture you can see in this OBE. But unfortunate part is that obviously we are all more interested in this goody picture and rather the true spirit of this OBE. So OBE is very much different from traditional education method, and it focuses on not on this traditional curricula, but it is based on the OBE is focusing towards developing curricula based on the outcomes, and it tries to inculcate the various skills like life skills, basic skills, professional and vocational skills, intellectual skills, and interpersonal and personal skills in the students. So that is what is desired from this OBE. So the components, as we had already studied earlier in this earlier part, that the vision and mission, they are important for us. So they should be structured and documented for the institute, because what you want to do is more important. What you have thought, I will be. What is your vision? That how my student should perform. All these things, they should be reflected in your vision, and then how it will be done in the mission statement. So there are many differences of opinions, but this is my way, that vision statement can be seen as very short sentences. Like in our Indian judiciary, we have Satyamev Jayate. Everywhere it is mentioned that Satyamev Jayate in our judiciary system. Okay. And the Doordarshan, which is nowadays people now do not follow it, but Doordarshan had this vision of Satyam Shivam Sundaram. Just by having studied it or just by having read it, you can see the picture of what these institutions are doing. You can very well clarify. Okay. So many institutions in our country, they are also having, even in army also we have, I forgot just now, but even our this in Olympic also we have this vision statement, higher and something. Okay, so vision statement is always there. It is a very short sentence, but you should be able to define the character of the institution very nicely. And it is basically a guiding statement with current and future objectives also, so that you can see that what we are going to do. So basically it is a character. Mission statements are simply elaboration of the vision, or rather in the light of the vision we can write 2 or 3 sentences, and then we define the steps or the pinpoint objectives. I'm just giving an example over here. Like in my department, Department of Electronics Engineering of RTU, our vision statement is very simple: to achieve academic excellence in electronics engineering. Now, what we mean by academic excellence? Academic excellence means that our students should be able to thrive. Okay, wherever they go, they will bring our name high. This is called academic excellence. Where in every examination, we should see our students doing in the merit. Wherever we go, we will find our students in higher positions in this should say in institutions as well as in manufacturing floor, everywhere in higher education, everywhere. So this is academic excellence. At the same time, our students should also have fundamental knowledge, and they should be able to cope up with the changes, etc., etc., all these things. So this is called excellence. And how we'll be achieving this vision is through mission statements. So there are 3 mission statements. Our department, this impart quality engineering education in electronics engineering. This is what we do. We have good teachers, and with this good teachers, with good curricula, with good academic program, we are imparting quality engineering education to them. Second vision, this mission statement is facilitate and motivate learning and research. Through our process, we ask the students for learning and research, and we motivate them. And to facilitate them, we have library, we have online resources, we give them the URLs, we give them the various resources, means we should say where the resources will be available, etc., etc. So this learning is there. Sometimes we pose challenges before them that do this thing, and then they will be finding out the various ways and means and resources, and that's how they will be getting motivated and facilitated. Then third thing, prepare technical expertise along with professional ethics as per the societal needs. We have an outcome towards, or rather we should have a vision towards the society also. So the technical expertise we should produce, which is a professionally very ethical, and what the society needs will be like currently our students who are going into this software programming, they need to learn Python programming. So we teach Python, Java, C++, and other languages also in our part. Then those students who are going into, let us say, this chip manufacturing, we teach them various softwares, cadence tools, etc., for this purpose also. So we give them the technical expertise, also. We prepare the technical expertise, and at the same time with professional ethics also, because by hook or crook, you are not supposed to get it. So my first thing was that I usually teach students with the licensed softwares, not with unlicensed softwares. That is the first ethical principle I have obtained. So I purchase the software either from the institute or from my own side, or if freeware is available, legal freeware is available, I teach with the help of that, but I do not do any piracy in it. So that is the ethics. So professional ethics have to be also inculcated in the students from the very beginning, and so this vision and mission can be achieved. And my department's vision and mission should match with the institute's vision and mission. So these are the vision and mission statement of RTU: to win eminent institute of technical education research through academic excellence and innovation to serve the need of industry and society. Yes, it is very big sentence, but at the same time, it is in consensus with our department's vision and mission. Then the vision, this mission statement of RTU: to provide quality education with focus on practical knowledge and ethics. Yes, to maintain a good student support system for their professional growth, to compete globally. Yes, and third thing, to promote an environment conducive for innovation, entrepreneurship, development, and research. Now you see that these 3 mission statements are not verbatim matching with 1, 2, 3 of them, but rather than if you try to map the, let us say, is first to provide quality education with focus on practical knowledge and ethics. It is mapping with the department's first and third, this mission statement, to maintain a student support system for their professional growth to compete globally. It is matching with all the three, and to promote an environment conducive for innovation, entrepreneurship, development, and research. It is somewhat additional because there are certain qualities which the department will be imparting, but some of them will the institute's own environment will be imparting. And so, because institute is larger body as compared to the department, so our department's vision and mission, they should be in consensus with the institute's vision and mission, and it will be more clear in coming up. So very interestingly, in between just this two lines, that the word society is very, very important in vision and mission statement. Why? Because man is a social animal, and so society is a very big concept, and it comprises of the human society to begin with, and all other stakeholders like parents, teachers, employees, future employers, clients, customers, family, friends, relatives, non-connected people, government, industry, etc. They are also members of the society. But if you think at a little larger perspective, from the larger perspective, you will see that even animals, plants, environment, earth, and all other natural entities, they can also be put into society as a whole. So entire universe can be considered as a society, because we have to live in this homogeneity of it. We cannot go against it. So that's why society is a very broad term. So it should be taken in that context whenever we are dealing in terms of this vision and mission. So this is basically very beautifully somebody has defined, and so I've taken it. An anonymous person had done it. So the functional domain of the entities are like you can see that the student is, let us say, in a small circle, which is housed inside the society. So the interaction of the student is with society, and it's a certain constituents like institute. Institute is one constituent of the society, and student is interacting with it. And inside the institute, we have department also. And student is interacting with the department. Probably the biggest share of student interaction is with the department, then somewhat with the institute, and then a little with the society. So, and you can see that these circles, one circle is housing the other one that way. So department, institute, and society, there are three circles which are one another, etc., etc. And then the student is interacting with them. So our learning, for students' learning, is not concentrated only in the department. Something will be taught by institute and something will be taught by society. But the student will have to learn on his own. So that is more important. So how the vision and mission can be achieved? So all these three entities, when they work together through the curricula or co-curricula or extracurricula to make a 12th standard boy into an engineering professional graduate, how the institute does it? Institute will prescribe the curricula, it will appoint teachers, evaluate the student and certify it. What the department will do? Department will conduct the classes and assist in evaluation, because some of the evaluation will be done in the department, some might be done in the outside world also, or the outside the department also. And so the student, what it will has to do? Student is required to study and subject to, he should present himself for evaluation. So when a student's evaluation is successful, it is the success of the department as well as of the institute, because we also have to assess ourselves that whether we are being able to impart technical education of good quality to the students, or whether we are attaining our outcomes or not. So engineering professional graduates are not engineering graduates, but There are persons with 4 to 5 years of working experience in the age bracket of, let us say, 25 to 30, or at the lower or middle tier in the professional career, and they are supposed to have certain qualities, which we call this PEOs, programs educational objectives. So I've just listed the 4 PEOs of my department. That there is strong foundation of electronics and allied subjects so as to excel in professional career and research. There cannot be any confusion onto it. It is very clear. Second thing is that technical solution for real life problems that are society and economically acceptable. If you provide a solution which is not economically acceptable, it's of no use. If it is not acceptable socially, it is again of no use. Third thing is that good communication skills, ethical values, and ability to work as a team. Now, these are the personal skills, okay, and means the student should have this leadership quality also. Students should be able to work as a team in a subordinate fashion also. It has a very good ethical values, and communication should also be there. And then the fourth one, an attitude for continuous learning by updating the knowledge to meet the ever-changing technical demand. That is also very, very important, that the student should not say that, no, it is over now, I will no longer study. No, I will no longer learn. It should not be there. There should be continuous learning, because the world is ever changing and every day we learn a little bit new. Okay. So, to make the students professionals, we have 12 program outcomes. Obviously, we have been prescribed by a global group of experts and documented in Washington Accord. And every engineering graduate program in India is prepared based on the program outcomes. And this one national body, National Board of Accreditation, monitors this compliance of it. And recently, our department has been awarded by one accreditation, that is in electronic instrumentation and control, where the coordinator Jitendra has also been a graduate over there. So I am very proud to say that Jitendra belongs to this department, which has been recently been accredited by this MBA. So now let us study about this various POs, program outcomes. So quickly we'll have a view of it, because I'm having 20 minutes left before our next program starts. So we'll quickly go through. So the very first PO, program outcome, first program outcome is the engineering knowledge. So what it is, when I define in terms of this graduate attributes of Washington Accord, it is that apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. Now the word complex engineering problems will be appearing again and again in various POs. Why? Because sometimes the engineering problems may not be related with just one subject. Like I'm using a chip or microchip, or let us say any VLSI chip, let us say CMOS chip or any other chip. You must have seen that it is black colored. Why? Because if it heated up, then the heat should be, let us say, decimated, and so the temperature should be there so that it will remain over there. From design point of view, it is not only a problem of electronics engineering, but it is also a problem of mechanical engineering. So because we have to make a fan also for that, whether we should say should say cooling fins should be provided, or fan should be there, or let us say some other means temperature, we have to do some force draft, etc., etc. So this simple electronics problem becomes a complex engineering problem sometimes. In medical science also, certainly, which is our area, Jitendra and me both have worked into that area. So we have to study not only just one discipline of engineering, but we have to study the multiple disciplines. When you are going for a product design, at that time you have to study the structure, the dynamics, the mechanical strength of it, then the aesthetics. Many such problems are coming up. So every problem is basically a complex engineering problem, and your specialization may be core to it, but there will be the surrounding this other engineering branches will certainly be there. So the solution should always be based on your specialization or other engineering fundamentals, sciences, mathematics also. Okay. So this is PO1. This is PO2, the problem analysis. If a problem is coming to you, you should be able to identify, formulate, review the research literature, and analyze the complex engineering problems, reaching substantiated conclusions using first principles of mathematics, natural sciences, and engineering. And what are the first principles of mathematics, natural sciences, and engineering? We try to go for the variables which are the most effective, and then we build upon. So the problem becomes, let us say, we can say y equal to some constant a0 plus a1x plus a2x square plus a3x cube plus a4 into x power 4, etc., 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 etc. Plus, if I want the first derivative of that, let us say plus b1 into x1 dot plus b2 x2 dot x double dot, etc., etc., etc. So this can become a complex problem, but the first principle is that we should first try to linearize it. Okay, so the constant should be there and other things. So you can make a series of that. So this series, nothing but it is a principle of mathematics. Natural sciences. Natural sciences, very simple. If you start taking the physics or chemistry or something of that sort, the various laws are there and they're very simple. Law of attraction, very simple. Newton's laws of motion, they're again very simple, but they do apply almost everywhere. They're omnipresent. If there is an action, there has to be a reaction. Probably one famous sentence by one politician was also like that, that a big tree when falls, then the land does make the movement. Again, from a scientific point of view, it was not wrong, because it is action and reaction, Newton's third law. But the thing was uttered at a wrong time, and this caused a lot of problems. So we have to apply things very consciously, and we have to identify, formulate, review research literature, and analyze the complex engineering problems. You should not go for the very simple solutions, and we should not go for any jugaad type of thing. Rather, we should do the problem analysis at length. Then design development of solutions. So design solutions for complex engineering problems and design system components or processes that meet the specific needs with appropriate consideration for the public health and safety, and the cultural, societal, and environmental considerations are there. Means the solution should be acceptable from all point of views. That is what is required. So your solution, it should not be out of the world. Like for many years, there has been a transatlantic motorway discussion is going on, that from San Francisco to some part in the France, probably Rouen, people are trying to have a tunnel at the bed of the ocean so that we can have a motorway. But there are technical problems in it, and so about $3 trillion is probably the cost of that. And so no government is able to afford it, and also people are not able to find out that whether it is feasible or not. So the solution, yes, solution is there, good connectivity is there, but the solution is technically not feasible at present. If it is technically feasible, then economically not feasible, and sometimes the solutions are culturally and societally not feasible, then they have to be again discarded. Sometimes they are environmentally not fit, then they have to discard it. So your solution should always be acceptable from all point of views. PO4 is conduct investigations of complex problems. PO4 probably is the most, we should say, emphasized type of this program outcome, that use research-based knowledge and research methods, including design of experiments, analysis and interpretation of data, and synthesis of the information to provide valid conclusions. This is basically a PhD. It has been debated over and over again and again. And we have, in a number of cases, I have also discussed that PO4 cannot be attained like this. And any institute which is saying that the PO4 attainment is 60% or 70% at the graduate level, we simply come to know that the institute is faking, because they have not assessed it PO4 probably. So PO4 in a way is there for us to check whether what the institute is doing, because they have not understood it properly. PO4 is in fact motivating your student to go for the research and higher learning, and at least should adopt to the research methodologies, how research can be done, how data can be interpreted, how the synthesis of information is there, etc., etc. And then moreover, valid conclusions you have been able to draw. So that is why PO4 is there. So PO4 is probably the most significant amongst all the 12 POs. In fact, there has been this given in the Washington Accord itself, that for complex engineering problems, how this PO4 can be done. So Professor Hugh had written this. Professor Hugh is again an electronics engineer and in this Johannesburg. So he had made this 5 points that how PO4 can be achieved. Okay, PO5 is modern tool uses. We do it always. Create, select, and apply appropriate techniques, resources in modern engineering and IT tools, including prediction and modeling of complex engineering activities with an understanding of the limitations. We know our limitations. Like people are trying to predict for corona, that what will be, when the third wave will be there, what will be the effect of it, how many days will it do, then after how many days the corona will go. So our prediction is going on. Many IT tools are there. But again, the thing is that appropriate techniques you have to apply, appropriate resources you should have, and also you should be judicious in your predictions. So that is very, very important. And when you can be judicious, when you know your limitations, it should not be. We know that there are certain things which are beyond our control. We do not know. There are gray areas. So while drawing the conclusion, you should mention the limitations also. So this is PO5. Then PO6, the engineer and society. So apply reasonable reasoning informed by the contextual knowledge to assess societal, health, safety, legal, and cultural issues, and the consequent responsibility relevant to the professional engineering practices. You must have it seen on many toys also it is mentioned that they are not fit for children under, let us say, 3 years or 5 years or something. Because why? It is the responsibility of the manufacturer to inform the customer that if given, let us say, to the younger children, it may be harmful. It is not good for their health. Even in movies also, it is clearly mentioned that this is not meant for certain audiences everywhere. So societal, health, safety, legal, and cultural issues, you should always take care. So whatever solution you are providing, any engineer, when providing us, then the society should be under consideration, that what will be the impact on the society, and the contextual knowledge should be there. The environment and sustainability, PO7. Whatever you do, you have to take care of the environment also. And if you are doing, let us say, you are making a bridge, very huge bridge, then what will be the impact of it? Many land will be going into this, let us say, this collection area. Okay, water bodies, some will be submerged. Then a lot of, let us say, trees will be, let us say, they will be displaced, or they will be destroyed. Flora and fauna will be affected greatly. So all these things you have to take care, but at the same time, the bright side is that so much of land will be irrigated, etc. So can there be any way, can we remove the trees from that catchment area and we can plant it somewhere else where they can thrive again? Can we shift the fauna also, etc., etc. So all these things we have to take care. Environment sustainability is very, very important, and they should be studied broadly. It should not like that some solution means over the shelf type of solution we should be able to provide. It should not happen. Okay. Now ethics, P08. Apply ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. Now, in this case, also, I would like to put before you in this lecture, I've used this Amulgal moped. Okay, so ethically, I cannot use it without the permission of Sylvester Lacuna and his team, because Sylvester was the person who made this Amulgal moped. So I wrote to him, I mentioned them that I will be using it for the non-profit purpose only. When they received the email, then I gave a call and I took their verbal permission that I can use it. They said that as long as you are doing it for non-profit purpose, we don't mind it. Okay, so that's why I'm using this Amul Girls Moped. So that is ethics. Otherwise, they don't bother. And nobody is going to say them, but it is the consciousness that I said that if I'm using their product, at least they should be able to know. So that's why, that's what the ethics. We should inculcate this type of thing among our students. Okay. Then individual and teamwork. This can be more apt at present because when we are fighting in the Olympics also, so many people are there who will be watching this Olympics also. You will know it very well that in hockey and other games also, the team spirit, how much it is important. And this is the same thing we have to put into our students also, that functional effectively as an individual, as well as a member or leader in the diverse teams and in multidisciplinary setting. It is possible that the side by side you will be having an engineer who is from a mechanical stream or civil stream, or you may be even working with, let us say, chartered accountant. At the time, it is more important for us to have a conversation or have something which is understandable to him also, and he should not be left upon. So the teamwork should be like that, that the team should be homogeneous. It should look homogeneous, although it is made up of heterogeneous components. So it should be like that. In communication, effectively, yes, everybody knows it. They communicate this program outcome number 10 is related with communication, that we should be effectively and complex engineering activities with the engineering community and with society at large. Like you have made a project report and it is not understood by anybody if of no use. But your report or even your PhD thesis should be such that it is understood by a person who is having very little knowledge of engineering. So the simplicity is probably the key to everything. So whatever your communication you are doing, it should be everybody should be able to comprehend with it. So you should write effective reports and design documents, make effective presentation, and give and receive clear instructions. If there is any ambiguity, then there may be chaos. There may be some problem. There may be loss of efficiency. So communication should be as clear as possible, whether in the form of instructions or whether in the form of presentation, documentation, whatever it is. So communication, effective communication, it is the key. So effective communication should be there. Then PO11 is project management and finance. That is very, very important. We are not science students only, we are rather applied science students. So should demonstrate the knowledge and understanding of the engineering and method management principles and apply these to one's own work. As a member and leader in the team to manage projects in multidisciplinary environment. This is very, very important. If you cannot control the finances, your project is going to fail. If you are unable to provide a solution within the given financial conditions, probably you will not be able to work. And even if everything is okay, but if you are unable to manage it within time, a given time frame, again it is going to fail. So project management is very, very important, and those who have understood it, those who have understood, they know the importance of it. And that's why in almost all engineering curricula, we have a final year project also. And at most of the institutions, partly it is being financed by the students themselves. Why? Why this provision is there? So that the student should understand the value of money and value of time. The student has to finish it within, let us say, 1 semester or 2 semesters, depending upon the curricula. And then the solution should be effective also. If you many of you must have seen this 3 Idiots also. There, the student is unable to complete the project within time, and so he feels lost. But the thing is that probably this happens when he is trying to manage things on his own. Had he had made a team, probably he would have done things better. So again, it's project management. How you harness the resources, that is important. How you harness the finances, that is important. How you manage, how you have a practical approach, that is important. So PO11 is based on that. And PO12, lifelong learning. So you should recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. Technology is changing very fast, and we have to be abreast it. And that's why in this moped, I found that this boy mimicking Mr. Amitabh Bachchan over there, not going by his other traits, but one thing I liked in this gentleman is that at this even age, he is 70 plus, he is still trying to learn a lot of things. He is very active on Twitter and he is trying to learn new and newer communication techniques, etc., etc. And even whenever in KBC I have seen, whenever somebody new, some new participant comes, he takes keen interest in his work, and that indicates the depth of his personality, that he is still at this age is keen on learning. So lifelong learning is very, very important. The way, and moreover, if you have this trait, PO11, PO12, not only as part of your engineering education, but PO12, lifelong learning, if you have a quest to learn more and more, you will never become old. That is very important, and one should not forget it. So, just to program outcomes that too long. So then we will be having course outcomes, and how we will be mapping. So probably we'll be studying all these things tomorrow in the last session. So I'll be winding up over here because I haven't given the time till 10:30. So it is 10:28 already. 2 minutes are left. If you have any question, you can ask, and then we'll be going for another program, that is the inauguration. Okay. So any question, anyone, please? Anyone wants to ask any question, please? Yeah, Jyotika Dubey, please.
Good morning, sir.
Morning.
Sir, I have one question.
Yeah.
Arts is a science and arts college.
Okay.
Science and arts college, and
Yeah.
we would like to implement this outcome-based education in our college.
Wonderful.
So,
Yeah.
so I would like to ask you, sir, that is it necessary for OB to be applied only in engineering colleges? Number one, and number two, the 12 POs as you have discussed. So a few of them are based on engineering stream. So while applying OBE, we have to left them, or we have to modify them as according to our college syllabus and curriculum.
Nice, nice, wonderful. I'm really glad that you asked this question. Many
Thank
of the
you,
people
sir.
are asking. Many of the people are asking this, and many of the people might not be asking, but they will be having in their mind. And now, two things: NBA and Washington Accord, they are meant for engineering education only. But in our country, we have another body that is called NAAC. Huh?
Yes, sir.
So if you look at the diagram of the framework of NAC, you will find almost similar type of things in NAC also. So
Yes,
this type of program outcomes are available with NAC also, and you can take help of them and you can study. NAC and NBA, they are much similar. very much simpler. And I have been inspecting the institutions under both the categories. So I have found that in sciences, arts, and other streams, also commerce also, that this NAC bodies, they are providing you ample guidelines for implementation of OBE.
Sir, is it available on NAC website?
Yeah, might be available.
Okay.
It is
Okay, sir.
available on Google. You can always go for Google. It is available on Google also.
Okay, sir. Okay.
Okay.
Thank you, sir.
Thank you. Thank you. So, Jitendra,
Yes, sir.
handing over to you.
Thank you, sir.
Thank you.
Thank you very much, sir, for this very nice and very informative session about
Yeah.
outcome-based education. I hope all the participants enjoyed the session and got an idea about what is basically outcome-based education and why we should go for it. So thank you so much for this wonderful session.
Yeah.
Dear participants, if you have any questions, please unmute and ask.
Meanwhile, one question from Ritesh Pathania is there. Will PO change as per course offered by the student? No. POs are consistent for this country. In India, we have adopted GA as PO. Okay. Thank you. Rest of the questions have been answered already.
So I think there are no more questions. So let's conclude this session. So we are very much thankful to Professor RANJAN Maheshwari sir, who spared time for this wonderful session. On behalf of all the participants, Engineering College Bikaner, ATAL AICT team, it's my privilege to extend vote of thanks to Professor RANJAN Maheshwari sir for this generous and informative presentation. With this, let's conclude this first session.